Light is the source for all things to grow. What will be the future of human beings without light? Light spreads all over the earth so people can see this beautiful world with eyes. What will happen to human beings without eyes? The incidence of myopia among children is 25% to 50% in Western countries, and as high as 80% in Southeast Asia areas. The survey found the incidence of myopia among adults doubled over the past 30 years. Nearly more than 30% of adults have to wear glasses. How did this happen? What's the reason of this? The reason is like this. The evolution of our eyes is out of step with the development of science and technology. During the past 30 years, electric light, TV, computer, and cell phone can be seen everywhere in our life and stimulated our eyes. Professor Richard Funk, a famous German ophthalmologist, had his report, "Blue Light Can Seriously Threat Retinal Neuron," published on European Journal of Neuroscience in August 2011. The report pointed out that continuous irradiation of blue light, especially the light of LED lamp, cell phone, and computer screen, contains a large amount of high-energy shortwave blue light with a regular frequency, will cause vision problems. This picture can show you how dose ultraviolet rays and blue light hurt our eyes. UVB with wavelength of 280 to 315 will lead to sunburn and red, itchy, and sore skin. UVB is a carcinogen, and UVA can cut through the clouds or glass, shine into indoor and cars, and irradiate into the dermis of skin to destroy elastic fibers and collagen fibers and blacken our skin. It also causes skin aging and wrinkle, and when it enters into lens, it causes cataract. However, the new international criterion of hurting eyes is a kind of mixed light called UVT max, which is composed of near ultraviolet, visible purple light, and visible cyanus light, whose wavelengths are about 380 to 400 nanometers. The features of shortwave and high energy of these lights can enable them penetrate lens and reach retina, where cyanus light may cause free radical. Free radical can make pigment epithelial cells in retina die and then make photosensitive cells in nutritious and impaired vision, which will finally lead to maculopathy, retractile lens, and myopia. This is horrible. By comparing the LED spectrum and solar spectrum, we found that LED with wavelength of 380 to 460 contain more purple-blue light, while solar spectrum of 500 to 600 as main wave band. Obviously, it is shortwave blue light that LED uses to get white light through the incitation of fluorescent powder, while the sunlight gets white light through yellow-green light. Light with waveband of 380 to 400 exists in all advanced iPad screen spectrum. So how can we handle the harm of screen? Never worry about that, because our magical IO2 screen protector can help you. The era of man-machine double protection of screen protector is coming right before you. Experiment 1. 100% filtration of ultraviolet rays. You can see the feature of 100% filtration of UV400 of our products. We use the ultraviolet rays of UV400 to test lamps. By irradiating the anti-counterfeiting printing on RMB 100 under the protection of two protectors, you can clearly see that the black protector cannot block UV400 light, but IO2 protectors can block UV400 light instantly, which proves that UV cannot be blocked by black color. Experiment 2. 100% blocking of blue light with length within 400 nanometers. We use the same two protectors as above mentioned. First, we use light of UV400 to shine on white papers. Then we can see dazzling blue-purple light with two protectors on hand in a parallel manner and move under the lit UV400 light. You can see that black protectors cannot block blue-purple light because there is still blue-purple light on papers. But there is no blue-purple light on IO2 protectors and only a little harmless purple light without any energy on the paper, since the blue light is filtered by the protector. Experiment 3. Blocking ultraviolet rays and avoiding melanin. We imitated the scene that having human being skin irradiated by UV without blocking of IO2 protector. Then we can find human being skin damaged by UV and produce melanin, which proves the light contains strong energy that it won't change its color with the blocking of our protectors, even after the long time of irradiation. Let's find out how does our protector work. The light transmittance of our protector can be as high as 78%, which is 10% higher than privacy protectors, though it builds a healthy wall between you and the LED screen, but it in no way affects your vision because you can just open it as opening your curtain of glass windows. When we put the IO2 protector between you and the LED screen, it starts working since it can know immediately which light is transmittable and which is not. As long as it feels electromagnetic wave of high frequency and high energy, the nanometer materials contained in IO2 will witness energy conversion. Protect your health